Okay, then we will be starting right now. So, welcome to our presentation. My name is Eclipse. I'm working on N4AG as a software engineer, mainly on languages and developer tools. Here with me, Sebastian.
I'm Sebastian. I'm a language engineering consultant at IDEs. And today we want to conquer the unknown world of JavaScript together with you.
And the drawings, we just want to mention the colleague that made the drawings for the presentations, because we can't show like that. So. Yeah. Okay. So disclaimer, this talk is not really about the internals of JavaScript and its particularities and the details of the language itself. We'll focus more on the tools and especially how we build headless tools for supporting JavaScript or similar thing.
So how do we conquer the unknown world? So first of all, we have to figure a ship that we need to sail with. So let's build a ship. And our shipyard is...
Yes.
Our shipyard is the Xtext framework, a de facto standard for building language support in Eclipse.
So the ship that we'll use to conquer the new world is N4JS. This is our extension to the JavaScript, which we'll cover in just minor detail but not too deep. We'll focus on the tools.
Of course, you also need a crew, and that would be our developer team that needs to also embrace N4JS, and thus we need to support their workflows and habits.
Yeah, and then we'll profit from the awesome applications we can build with these tools and the languages, but they will be scoped for the purpose of this demo in their complexity. So, the shipyard.
The shipyard is the Xtext framework, as already mentioned. So with Xtext you can build awesome ships. Pretty much every language that you can think of can be implemented based on the Xtext framework, but especially well does Xtext play with Java. So languages that run on the JVM are getting superior support or better support than non-Java languages. So you have integration with JDT, or you get plugins for to copy your build tools in. Of course, there are established patterns and project structures that are well supported by Xtext and Eclipse.
So, but we want to conquer JavaScript instead. So here, first of all, this landscape of this land is much different than Java. The build tools are the much broader possibilities. We have there like several projects for project scaffolding. There's different package managers that piggyback themselves, so it's not a matter of using just one quite often. And the other tools for bundling the code, obfuscating, and other things. The test framework landscape is much broader. It's not just JUnit 5 or JUnit 5 or 4. It's just lots of test runners, assertion frameworks, and the test libraries or frameworks in general. And one thing, the project structure, which is not really, technically it's there, but it's just agreed on community standard that the NPM introduced package.json to describe basically the artifact that is stored in the NPM registry, and then everyone else just piggybacks this file to define like a project that the tools can support. The ship.
The ship, exactly. So now that we know our wish list that we need to go figure out, let's take a look at our vessel, which would be N4JS, a superset of JavaScript. The unique property of N4JS is actually the integration with the N4 platform. So as a platform, we also offer APIs and security concepts to be able to deploy applications to the store, and that is what is supported by N4JS. On top of JavaScript, we also build sophisticated type inference and static type systems. And over time, so this project was actually, you don't build a ship in a year. So this project was started in 2013. So over time, we had to follow up with the development of JavaScript itself, supporting features that came up in recent versions of scripted JavaScript.
And on top of that, we did add a few things to the language that we found are really important for us. Like, for example, dependency injection that is baked into the language and supported by the tooling then of reflection API and and other things. But this is not about the language, it's about the tooling. So first of all, we have the N4JS IDE, which is based on Eclipse, so it contains all the good parts you would expect, the incremental compiler, the quick fixes, content assist, and the validations and navigation in the code back and forth between the modules. But also the headless tool that the internals will describe a bit in a minute. That supports compilation, running the tests, executing the code, and in both cases we are emphasizing this. Because of the nature of the language or the underlying language, the JavaScript, we are integrating with Node and NPM packages. So the crew.
The crew it's a special crew, of course, because we are talking about JavaScript developers here that we want to attract.
Yeah. Maybe I will say this is my friend Joe, the developer in our company. He's a former employee of Yahoo Mobile in US. Now he's working with us on our internal projects, and we'll use him as a representative to ask what the JavaScript community needs. So, what would Joe need from the language and the tooling?
Joe would need, first and foremost, command line support. So in his projects, he has a magnitude of shell scripts and basically shell scripts that he used to run recurring tasks all the time. So it needs to integrate with Node.js and the NPM package manager, of course, otherwise it would be pointless. Joe would definitely want an IDE that behaves like all the other IDEs out there, like Maven and Sublime, which are, from my point of view, more or less text editors. And Joe is a very opinionated developer because he will run anything in Java to do something on his machine.
Which is an interesting approach also because for getting the project done, he will be happy to install any number of NPM dependencies to get the job done. And this is where this extra support for Node.js and third-party tools is important. For example, this is the list of the transitive NPM dependencies that Joe has in one of his projects that he's working on internally in the company. This fast scroll was roughly 850 dependencies that he pulls from NPM. And what is important here, I'll use my special pointer, is the 80 plugins to the bubble, and the bubble is the N4JS transpiler. So he writes N4JS code, we compile this code to the JavaScript, but the JavaScript is also not well defined one version, it's a moving target based on features. And then here the bubble comes into play where the specific plugins continue, create next compilation pipelines to transform JavaScript to something that will work in a specific browser in a specific version. So the challenge, that's a bit of challenge to tackle this.
So what we try to do is first and foremost convince the JavaScript developers to use N4JS, and for that purpose we had to integrate with the existing infrastructure and develop tools and especially NPM, as we already mentioned. They're project specific that can be used or not be used, and in the end we had to find a compromise that supports everything without putting too much burden on the development effort for the language itself.
And it's not only the JavaScript that imposes its own particularities, but it's also the parallel efforts that we have to do of working on the language design and the language spec and taking care of that. Then the tool support of customizing Eclipse here for compiling and providing all the features we need. And then we need to provide command line tool because every project at the end of the day should at least end up in some kind of CI system. So in here, important part that we think is crucial is the single sourcing of IDE builder, for example, in the compiler. So we try to reuse as much implementation between the Eclipse IDE or our custom IDE and the headless tool to avoid different implementations and different behavior of the compiler, for example. So, despite the odds, let's do this.
So let's look into the details, the more technical details here when it comes to the single sourcing. So back in Xtext 2.9, the Xtext framework started supporting command line compilation by providing abstractions over what we get for free in Eclipse. So in Eclipse you do have projects in the workspace, and the project contains source folders, and so there's a well-established API to work with this. And with Xtext 2.9 we also added the equivalent on the command line. So we do have a workspace configuration that contains a bunch of project configurations and source folders. So it pretty much mirrors the abstractions that we find in Eclipse.
It's all great, but the crucial point here is, for example, the Xtext 2.9, and with N4JS we started with Xtext 2.4 in 2013. And at that point, this API was not there at all, so we had to come up with our own solution, which is almost the same abstraction over the project. Here there are two blocks, but it's headless, so let's treat this as one big class. So then we would have also three boxes, and they abstract the workspace, the project, and the source code container. Without diving into details of those APIs, just by glance you can see that the API surface of this abstraction is much broader than what is provided in the Xtext core. And there are good reasons for this. If we just go back here for a moment, if pirates with lasers now, if we look at the project config, there is nothing there that would say anything about that your project can have something like dependencies, or that project can have version, which in software development is rather crucial. So that's why it's one of the reasons why our API structure is a bit different. But moving on, another part would be the workspace.
Exactly. So one goal was that all the language-specific implementations, and for we do not only have one language, but we implemented a couple of languages at the same time. We wanted all these languages to work against a common API when it comes to Eclipse and the runtime, and therefore we introduced this API in the middle here. So we have the core, which represents the workspace, and then we have and this API shields against the Eclipse-specific implementation. So one thing that we did was avoiding any use of the Eclipse resource API by providing our own abstractions here.
Yeah, so the middle part is our implementation of all the logic that is required for supporting projects, and as Sebastian said, the left part is bridged to the Eclipse iResource, iFile, iProject, etc. In the headless case, we have similar thing. We use the same implementation for the implementation of the logic of handling the projects and the workspaces, and the green part is bridged to the Java I/O basically, and that's the whole picture. How we try to achieve single sourcing in as much as possible. For example, for the project abstractions and handling those. Assuming that we solved all those problems, now we want to set up our application and run. So how do we create this at runtime?
So this is a subset of the classes that are involved in Xtext languages initialized in Eclipse. So what we start with is a language-specific injector that is composed from language-specific modules for the UI and for the runtime. I do also have a laser pointer, right?
Yeah.
Period appearance. So we have a runtime configuration aspect that contributes to the injector. We have the UI configuration aspect that contributes to the injector, and everything together makes the configuration for a language Eclipse. But of course, there are also shared services that are usually provided by the platform itself, like the builder or the builder stage, which is the index implementation in Xtext. And since dependency injection in general is a good idea, we also initialize those from another injector that is shared across all languages that are deployed in an Eclipse instance. So we have a shared injector that is initialized from the shared module, and the singletons from the shared injector are then provided to the languages themselves as instances, so that all languages can have access to the very same objects and work with those.
So it seems like the Xtext solved all our problems for us. There's whole mechanism, all APIs. We can do this. The boxes are purple because it's an Eclipse word, the activators, etc., extension points, all great. Let's do this in headless case and see what Xtext provides us there. That's actually it. That's all there is for this purpose. The dotted box on the left is the incremental builder. It's also something that was added in Xtext core 2.9, and basically that's it. There's only language runtime module but there's no recipe for injection and setting up the headless application based on the Xtext framework. So we had to come up with something on our own. That's how we approached this. The N4JS C class that is here on the top is our entry point to the command line tool. It's using the Xtext generated runtime module to inject whole application. In particular, it creates the builder. It is our custom implementation of the clustering builder. That, by the way, Xtext core, this builder is not clustering builder. Recently, there was a bug on GitHub that it runs out of memory if your project is big enough. So we are still sticking with our own custom implementation. And what is important here is like the boxes on the right is our common implementation that we use between Eclipse and headless case. And in some cases, we just take advantage of the APIs provided by the Xtext. And at the bottom, another box, two-color box, that the generator and the backend of the compiler is the same in both headless and Eclipse case. And just for comparison, that is the comparison.
So as you can see, what we achieved is that we can reuse most of the stuff that is language specific or provided by the framework itself. So we do have the interfaces for the resources, the NF API, we do have the iGenerator that implements the interface how you can write your compiled code. This is the number 4 N4JS implementation of the iGenerator, and the very same instance or the very same implementation can be reused in the Eclipse environment as well as in the runtime environment. So we don't have to duplicate the generator itself, and still get the benefit of all the optimizations that we could apply in the Eclipse as well as in the headless case.
Now we'll do a small demo to say just that it's not only this, but we actually have something that works. So first of all, this is the IDE. This is the just one cleanup. This is the IDE that we use for doing our application. This is just entry point to the application. First, I will show how it runs, and then we'll talk about how it works. I'll take advantage of the Node.js integration, and I will execute this code in Node.js, and it's a command line application, so it's just printed output. Basically, it's a weather application. We just ask what's the weather in Ludwigsburg, and the internet says it's 16 degrees and it's partially sunny, and we have some forecast for next days. So how does it work in general? So this is the N4JS. These are some features we've added to the language. The imports and the modules is something new coming to JavaScript. This part is a setup of the component. This is our built-in dependency injection that we define the components that have to be created at runtime. And this is our static main, basically, from Java, creating injector, getting the instance of the application, and checking what's the weather. We can navigate there. This is very simple application, actual application code that just has some weather engine injected, and it just acts this engine with the asynchronous method for what's the temperature now. And if we go there, it's a bit more code. This doesn't matter, it's just basically filtering for the output. But the important part is that actually this is where we get the actual weather data from. So if I jump to this, this is actually, we are not doing the heavy lifting on our own. We delegate to the npm library. This is actual code of some JavaScript npm library that takes the weather from MSN, apparently. On the left, this part is the view, is the view of our npm dependency, some weather.js. It has index, some data, whatever there is in npm, it appears here. How do we know that we're supposed to use this? We actually have a project structure. There is a dependency defined here, and this particular dependency comes from npm. I have this view for managing no npm libraries. I can, for example, uninstall this library. It's removed from my project, and now I have error in manifest saying, okay, you don't have this dependency anymore. But we can quick fix this, and then depending on the network and external factors, the library is pulled from npm in version, it was latest version was installed here, and the error is gone, and that's what's happening here. One more thing I can show is that we also integrate with running the test. I can execute the test again in the node engine. This is some output from the tests, and we see that the tests have passed. For example, this test passed, and if we look at this closely, it checks if the weather in Berlin has 5 degrees. Interesting. I know what will happen, why my assertion works even though we fetch information from internet. Solution is simple. Because we don't do the connection to the internet on our own, we are using weather engine, so we basically reconfigure injection with our custom bindings. We rebind the weather engine to our mock implementation, and my mock implementation returns whatever I want it to return, so I can run my unit test instead of like relying on whatever is now, whatever LSN says. This is a very brief overview of the IDE, but it's not only about the IDE, it's about the headless tooling. So first I will call our headless tool. It's implemented in Java. For start, I will just print help. This is quite long delay for printing help from any kind of program. Reason for this is I had this brilliant idea some time ago that we switch our headless implementation to be full-blown self-contained headless OSGI application, and it works. But there is something with managing the bundles and dependencies, and the startup time comes actually from the storage class in Equinox implementation. It's a detail, this can be managed, but I'm not yet sure which direction I want to go, so we'll see how we do this in the future. Moving on, let's do the actual work, actual calculation of the command line. I will just do this.
I think you renamed it to call me.
I did, thank you. So let's just do it like this. So this is, I will use the script to call the compiler. Basically, I am calling the compiler. I'm telling it to compile all projects. I'm saying where the projects are, our weather application. This is interesting part because in this line, I'm telling my headless tool where it should fetch additional dependencies. And this is for the CI integration to, no one will quick fix on CI to get dependency from NPM, and you don't want to check in your dependencies into your repo. So we use, I will show the target platform file. Basically, its inspiration comes from target platform file in Eclipse. And then we just say whatever you install from NPM, put it in this location, and then compile and run with Node and run this file. So I can do this. It will start up again, so a bit startup time, but at this point, basically, compiler will it's not a compiler, it's actually build tool. It will compile the code, it will fetch dependencies, what we see now from NPM, compile everything, assemble the class paths, and execute everything with Node.js, and we get the same output, unless the weather changed in between. One quick word I can say about the for Travis, if I push my project is on GitHub, and it of course has Travis build, that is failing right now because we just moved our N4JS project to Eclipse Foundation, and now it's part of the Eclipse Foundation, but we haven't yet provided public release of N4JS. So our NPM that is publicly available in the NPM registry, that is called here, that wraps around compiler to provide JavaScript API is just a bit outdated, and next week's I will be providing public NPMs once we get Xsemantics public build, Xspec public build, and then we prepare N4JS public build, and the NPM integration will work again in few days or weeks, depending on my load. That was the breeze through the demo, and these are our learnings.
So most importantly, whenever you build a language, you have to know your target audience, your user group. You have to support the existing workflows rather than changing everything from scratch. Otherwise, the acceptance factor will just be way too low, and everything will be prone to fail in the end. But there are more learnings, right?
Yeah, more learnings are basically the first of all, with Xtext, what we basically showed in this presentation, you can do everything, but the support you get from the framework is also limited. And at least at this point in time, as far as the headless tools and command line support is concerned, the Xtext does not provide really that much. And it's hard to, and the no 5, 10 or 15 minute tutorial that you see on the Xtext page will tell you this. It's something that you have to discover by trial and error. And then you face this single sourcing challenge, which it's a trade-off. You can do single sourcing with some trade-offs, or you can decide to have two separate implementations, which also has its own concerns. But it's a design decision, I guess, for everything.
And whenever you build a language, eventually it needs to be compiled on some CI server. Being it a language that is a full-blown programming language, or another language that is just compiled down to say Java, then in any case you need the support on the CI infrastructure for that, and thus you should start quite at the beginning to support that, and not only add command line tools and headless compilation at the end, because that will never be on par with the support that you get in the compilation in Eclipse otherwise. So
we breezed through the presentation to finish on time, but we can answer any questions if there are any. Please don't be shy.
One, two, three. No more questions?
Okay. Right. Then thank you for joining our presentation and enjoy the rest of the conference.
Thanks.